Hello everyone, welcome back to the class. This is ECE341, the probability and the random process course. We just have the midterm exam 1 on Monday, right? So today we will just go over the exam problems. So today it should be a short class. Yeah. Okay, let's go to here. Now here's the document camera. We go to here. This is a ECE341, the 6-week Wednesday's class. We just have the exam on the Monday of the same week. Now we go over the problems. Solution of the midterm exam 1. Okay, the first problem. Let's look at the problem. I have a problem here. Yeah, this is the first problem. Okay, the first problem, we have dice, 6-sided dice that you were. Oh, I lost the word here. Sorry. We were roll ones, right? Roll ones, and then RI. It is the event that roll is I. So this is just can you see it? Like I see both, right? Yeah. RI. It is just I. I will run from 1, 2, 3, 4, 5 until 6. Actually, 1 to 6 is the sample space. Right? And then we have J, which is you will have row is larger than J. So it will be larger than J will be J plus 1 until 6. So here J should be 1, 2, 3, 4, 5. No 6, right? We don't have 6. Larger than 6 is impossible. Okay. So we have these. Yeah, if you want, you can put the sample space. 1, 2, 3, 4, 5, 6. And suppose this is a fair one, right? Did I mention that? If I didn't see that, suppose you know it will be a fair one. So the probability of each I, it will be 1/6, right? This is given. This part is given, and here's our I and RJ. All right, now we can start to calculate what are the problem. What is the first one? A is what is the probability P of R4 given G2 as condition. Okay. Then this one, it will be by definition it will be R4 intersection with G2, the probability of this event in the numerator, and the denominator it is the probability of G2. Yeah, as if you use G2 as a sample space now. G2 is condition. We suppose G2. We already have G2. Okay. Then intersection of R4 and the G2, it is just 4, right? It is just 4. G2 equal to 3, 4, 5, 6. Right? Larger than 2. Greater than 2. Right? 3, 4, 5, 6. And the intersection with R4, it is just this one. 4, and here is G2. Now we know the first one, numerator is just one element, so this probability is 1/6. And the G2 you have 4 elements, so this is 4 out of 6. Then the result will be 1 out of 4. It looks like just here, numerator contains 1 element, and the condition you have 4 possible result. So 1 out of 4. You can get this directly. But of course, you are supposed all of them they have same probability 1/6. If they are different, then you have to calculate each one. Alright, this is A. Then B. What is the conditional probability that 5 is rolled given the roll is greater than 3? So this is the problem is stated by a statement, by a sentence, right? but we can write in a formula in a math symbols. Here's a probability of 5 is row, so it's R5, and the condition is greater than 3, so it's a G3. Okay, so this is a probability of R4 G3 intersection as a numerator, and denominator is the probability of G3, similar with A. So this will be 1 out of 6. This is 5. 5. So the intersection is still contain just one element, right? This time is I put here G3 will be 4, 5, 6, greater than 3, and G5, R5 is this one. Right? R5, the intersection is just this 5. So numerator contain only one possible number. The probability is 1/6, and the denominator is the whole G3. The whole G3 we have 3 elements, so it's 3 out of 6. Then the whole thing is 1/3. Okay, this is the B. And C, similar, right? C, what is G3O? O is the event. Event that row is an odd number. Okay, O is odd number. So now we want to have the probability of G3 on the condition odd number. Then it will be probability of G3 intersection with O with odd function, odd, and out of the O is odd. Then here you can write G3, you will have 4, 5, 6, and odd there will be 1, 3, 5. Then the intersection will be which one? The 5, right? It's 5. Okay, so numerator just one element, the probability is 1/6, and the denominator we have 3 elements, the probability is 3/6. So totally is 1/3. Alright, this is a C. And the D, given that the row is greater than 3, what is the conditional probability that the row is odd? So now this time is calculate the probability of odd given the condition is greater than 3. Calculate this. Similar, this is also a numerator is the intersection of these 2 events, and the denominator now is G3 as a condition. Okay, so this is what O G3, same with this, right? It is 1/6, 1/6, 1/6, and the denominator is G3. G3 is here. 4, 5, 6. So this is also 3/6. Totally is 1/3. Alright, so this is the D. Okay, this is a problem, the first problem. Just some basic calculation on the probability and the conditional probability, right? Okay. And now we check the second problem. Okay. Second problem. Now we have 2 biased coins, so they are not fair one. Coin A comes up head with probability 0.4. Coin B comes up head with probability 0.7. And we do not know which one is which one, so we choose one coin randomly and flip it. Then okay, now we can have result. If the flip is a head, we guess that the flip coin is B. Otherwise, that means if the result is the tail, we will guess that the flipped coin is A. Okay, so this is the description of the experiment. What is the probability PC that you guess is correct? Okay, so you will check which one is correct. Okay, then to solve it, first of all, you give describe of the whole thing, because this experiment contain 2 steps. So you give we can use a structure, use a tree structure to describe the whole process of the experiment. We start, then we pick. First step, we pick a coin. Pick a coin. Then we can have 2 possible results. We pick A or pick B, and equal likely probability, right? You have half chance to get A, another half chance to get B. And then you will flip the coin. So either case, you have 2 possible results. Right? You have face or tail. Face or tail. And the probability is for coin A come up head, or I say face, this head, right? His head. The head with probability 0.4. Okay. And another thing we know is coin B comes up head with probability 0.7. Right? This is a given condition. Okay. Then we can have some numbers directly, almost directly, right? So this should be, right, when you have a coin in head, you have head 0.4 as a probability to head, then the probability to tail will be 0.6, right? The summation should be 1. Here is similar. You will have 30% chance to get tail. Okay. And then we will guess. We will do a guess. You guess the flip coins B if you get head. So these two cases, you will guess it is B. It is B. You guess it is B. Now when you get head, you guess it is B. And another side, if you have tail, you will guess it is A. It is A. This is your guess. And then we will check the probability of C. What is C? C, your guess is correct. Right. C, the guess is correct. Then you will check which one is correct. Here you guess it is a B. It is not good, right? Correction. Correct or not? This is not, right? You think it's a B, but actually it is A. And this case, you get tail, so you think it's A. Okay, this is good, right? In this case, you get head, you think it is B. Okay, it is good, right? In this case, you get tail, you think it's A. No, it is not. Right? You think it's A, but it's not A. Right? And it actually is B. Okay, so for correction, we have these 4 cases. We have 2 of them. They are correct. So the probability PC, it is just these 2. You add them together, you get the whole probability. Okay, what is probability here? What is probability here? We want to find the probability here. This probability will be probability equal to half times 0.6, and this probability equal to half times 0.7. Okay, so now we have result. This is a 1/2 times 0.6 plus 1/2 times 0.7. Right? You go along the path. Half 0.6, the first term. Half 0.7, the second term. And this will be, okay, 0.3 plus 0.35 is 0.65. So this is the second power, right? Second power. Okay. Now check the third problem. Now we have a binary code with 4 bit. Okay, so you need 4 0 or 1s to form a word, and in each code word a bit is a 0 with probability 0.6 and independent of any other bit. So there's 4 bits, they're independent of each other. Okay, this is problem 3. And A, what is the probability of the code word 0.0101? Okay, the probability of 0101. Then we know we have 0 with probability 0.4. Let me see, point which 0 with probability 6. Okay, we have 2 zeros, and the other 2 will be 0.4, right? So that's it. There will be some number, 0.24 square. What it is? Yeah, I lived here. All right, it's not a big deal. You can use calculator to find. And B, what is the probability that the code word contains exactly 2 ones? So this is a similar way the first one, but first one, the word is given. Just the first element is 0, second element is 1, then 0 again, then 1 again. No other choice. Now it is the case, you have 2 of them, they are 1, but they put 1 in different places, right? So this one will be the probability of code word with 2 ones. And this is how many words can we have? We totally have 4 locations, right? The whole word is 4 locations. 4 locations. You will put a 1 or 0 or 1 in each location. Then we need to pick 2 locations out of these 4. So 4 choose 2. 4 choose 2. And the other 2 locations will be zeros, right? 2 of them are for 1. The other 2 for zeros. And each one you have this probability. Okay, so this is the result. And 4 out of 2, we choose 2 from 4. This is a combination, right? The number will be 4 factorial over 2 factorial and 4 minus 2 factorial times 0.24 squared. So yeah, I can write this one 4, 3, 2, 1 over 2 times 1, and this is 4 minus 2, there will be another 2, so 2 factorial over 2 times 1, and we can cancel this 4 and this 2, it is 6. It is 6. Okay, it already 6 times equal to 6 times 0.24 squared. Okay, I leave it here. Alright, and this is the second problem. Third problem. This is third problem. And we check the fours. Now is okay, we have a random variable x, and we know the CDF of x. The problem is we want A, give the graph of the CDF. Second, write the PMF function, the mass function, probability mass function. And C is we want to find the probability. So we have 3 questions. For A, draw a graph. Okay, so this is actually this is just some math, right? Basically, we have x as a variable, and the function is f(x) of x, and this value, when x is smaller than 0, it is 0, so it will be this part. It will be this part. And do not contain 0. Yeah, if you want, you can put the empty circle here. That means this value when x is 0, the function's value is not here, so it's an empty circle. And here at point 2 we have a solid circle at point 2. Okay, this is when x runs from 0 to 1, and do not contain 1. Right? The second interval contains 0, do not contain 1. The value is point 2. And then point 5. Point 5 is x run from 0 to 1, from 1 to 2 is point 5. Do not contain 2. Okay, and the next will be point 8, and x run from 2 to 3, and the function value is from just a fixed number, point 8. Oh, I need more space. And the last will be 1 from 3 or larger than 3. Here's a solid, sorry. This is a empty. And larger than 3, larger than or equal to 3, it is 1. Okay, so this is the CDR. This is CDR. Right, this is A. The B, we want to find the Px of x, the mass function, right? Probability mass function, PMF. This one you can you have the graph, right? Just look at the graph, you know the answer. So you see, we have looks like stairs, right? We have several places. We have a jump, so each jump is a value here. So the first jump is point 2, right? From 0 to point 2. This happened when x equal to 0. Okay. And the second, this is a jump from point 2 to point 5, so that is a point 3, and x equal to 1. And third one, when x is 2, we have jump here from point 5 to point 8, so the distance it jumped up is point 3. Right. And the last one, another jump is here from 3, at 3. So when x equal to 3, we have another jump from point 8 to 1. So jump is point 2. And okay, zeros, otherwise, other values, all the other values of x. So we have PMF. And here be sure to write the value of this function for all x. So we need this, right? We need this part. If you do not have this part, then you only have the value when x equal to 1, 2, 3, 0, 1, 2, 3. But when x do not equal to these 4 numbers, okay, all the other values, what is the mass function? It is 0. Okay, this is B. Alright, now C. We want to find the probability x larger than 1. Right. This is a C. We want to find this probability x larger than 1. Then, when you have the mass function, you can make sure this experiment, the possible result will be 0, 1, 2, 3. And the related probability are here. Right. Now is a 0.2332. And now this event we want to find the probability. And what is this event? We know 1, 2, 0, 1, 2 are possible values, right? So here you look at here, this one, it is x larger than 1, it is just x equal to 2 or 3. Larger than 1, right? Only 2 and 3. And then the probability is the mass function at x equal to 2 plus the mass function when x equal to 3. Equal to 2 is 0.3 and equal to 3 is 0.2, so it's 0.5. Good. Just in the middle. Larger than 1. Larger than 1, there will be 2 and 3. Half. Okay. I think it's good. Yeah. Okay, this is problem 4. Alright. That's all for today. Right. We have 4 problems. If you have any more questions, you can ask me. Go to the office hour. The next Tuesday, every Tuesday afternoon, we have the office hour, and you can also post your doubt your question in the Piazza discussion bar. Okay. All right. That's all for today. See you next time. Bye bye.